Hello everyone, my name is Noel Singh and I'm a Senior AI ML Solutions Architect. I wanted to discuss the key considerations for selecting a large language model and an embeddings model for RAG type use cases. So let's say you have a corpus of documents and you want to make these corpus of documents searchable. You initially have to turn these corpus of documents into document chunks, and that's smaller token representations of your data. We create chunks because it's more memory efficient than actually scanning in the entire document set. And then you'll need to create embeddings of these chunks, which is essentially a vector numerical representation of your data. So in order to do that, you'll need an embedding model. And once you pass these document chunks through the embedding model, you'll need a location to store it in. So we usually store these in a vector database. And at Amazon, we offer two variations of vector database, two more common variations, which is OpenSearch and Kendra. Now, once the documents are chunked and they're turned into embeddings, it's important to note both the textual representation and the numerical representation of the data is going to be stored in the vector database. So let's say that you have a user and they submit a query. And the query as well needs to be turned into an embedding. And in order to do that, the query will be passed through an embedding model, and the embedding model will turn the query into a vector representation. So it's essentially think of it as an array with a series of floating point numbers. The amount of numbers contained in that array is referred to as an embedding dimension for a model. And once this vector representation is done, there will be a similarity search that's performed by your query in conjunction with the document chunks within your vector database. So there's a programmatic calculation that's done to see which vector representations of your query are closely related to the relevant document chunks. From there, a set of document chunks are returned back. Now, what's important to note in selecting an embeddings model for these type of use cases is the key considerations. One is embedding dimensions. So as we mentioned that embedding dimensions is a vector representation of your data. And we mentioned that the amount of numbers stored in there is the dimensionality or the output vector of the embedding dimensions. The reason that's important is the output vectors essentially define semantic similarity between various phrases, queries, and in our case, document chunks. So a higher dimensionality model will usually yield greater results in terms of semantic or relevancy search. So in Amazon Bedrock, we offer the Titan text embedding model, which has a dimensionality of 1,536 floating point vectors. And so essentially, whether your query is passed through that model or document chunks, it'll be turned into an array, a vector array of 1,536 floating point dimensional chunks. So now we retrieve the chunks, and we need to, in order to store these chunks into the vector database, another key consideration of an embedding model is you need to be aware of the embedding model's context window size. And essentially what the context window controls is your document chunk is being turned into a vector representation, but when it's passed through the embedding model has a context window size, and if the chunk exceeds the allowable context window size in order to turn it into an embedding, the additional tokens or text of that chunk is discarded. Now, this could lead to poor search results because of loss of context. So it's important to be aware of the embedding model's context window size. With our Amazon Titan text embedding models, it can support a context window size of 8,000 tokens. So in this case, let's say we had a document chunk that was 8,100 tokens. The additional 100 tokens would be discarded because it doesn't fit in the 8,000 token window context. And the reason that's important, again, we mentioned that you want all of the chunk to be represented in the embedding. Now, we performed our query. Our query was turned into a vector representation. A similarity or relevancy search was performed on the vector database, and now the respective textual chunks were retrieved. Now, let's talk about some considerations in selecting the right large language model. So what will happen is these chunks that were retrieved from the vector database will essentially be sent to a large language model along with our query. And one of the important things to note is a large language model itself has a context window. And so let's say that the large language model has a context window size of 4,000 tokens. What are some of the items that that context window includes in a large language model? So let's say your query accounts for 1,000 of those tokens. And your query is essentially your prompt, your textual guidance that you are giving to the large language model, the instructions. So now we've accounted that if you have a context window for a large language model that's 4,000 tokens in size, and your query accounts for 1,000 of those tokens, it leaves you 3,000 tokens essentially to be able to make usable with that chunk. So now that query returned some document chunks that were relevant to the query. So another portion of that context window, let's say 1,000 chunks, we're just putting arbitrary numbers out there, would be of the document chunks. Now, you also have to account for chat history, maybe previous queries, previous questions that the model is maintaining a state of, and that would be the chat history. So let's just say if each of these were taking up 1,000 tokens apiece, so we're at 3,000 tokens. That limits us to a 1,000 token window of our completion. And our completion is essentially the text that the large language model generates. So now you'll see how we've taken a 4,000 token context window and filled it up with a query, document chunks, chat history, and completions. And we filled up the large language model. And the large language model takes in the query and takes in the document chunks, the relevant content that was coming in from the vector database, any additional chat history, and generates a completion, and the completion will be the response to the customer. Now, it's important to note, this is the context window, but how do you select an adequate large language model outside of the context window? And you need a large language model that has the ability to reason well. And usually the best way to determine that is to check a large language model's benchmark scores on any of the key benchmark sites, Helm, and other, on reasoning tasks in specific, okay? So once you have the reasoning tasks, another thing you want to do is just do some sample prompts of this large language model. The Amazon Bedrock Playground is a great way to be able to prompt the model and check its reasoning capabilities. Once you have a large language model with the proper reasoning capabilities and essentially the proper context window respective to your use case, you're ready to RAG. So in conclusion, I want to mention that the key selection criteria to selecting a good embeddings model is accounting for the context window size and the output vector dimensions that the embedding model produces. And for a large language model, a key selection criteria is your context window size and its ability to reason. Don't forget, you'll need to select a proper vector database. We offer several options in Amazon. Two of my most common ones are OpenSearch and Kendra. And don't forget that you can use the Amazon Bedrock Playground to perform reasoning tasks with a model that's not necessarily contextual to your data to check the model's reasoning capabilities. I want to thank you for watching this segment regarding demystifying RAG, and good luck on your RAG journey. Thank you.